Alright, so I think I'm recording. Let's take a look at this problem number 2. They are asking us to identify intervals on which the function is increasing, decreasing, or constant. You can relate this back to the idea in Algebra 1 of a slope. Here I always enter the graph and move from left to right. As I come into the graph on the left, I hit an arrow. I interpret that arrow that it gives me two pieces of information at once. Gives me information about the x coordinates, and it gives me information about the y coordinates. So since the graph is moving, as you move to the left, it's moving down. The x values are getting smaller. They're heading towards negative infinity, and the y values are heading towards positive infinity. Over here on the right hand side, again, the end of the graph is giving me two pieces of information. I want to break that up into a single piece of information, so I know that as you move to the right, the graph is going down, so the x coordinates are heading towards positive infinity and the y coordinates are heading towards negative infinity. So the function is increasing if when x increases, y also increases. So as I move from left to right, the x's are increasing. Okay, so as I move from left to right, what's happening to the y coordinates? So pick any 2 points in this yellow shaded region, and you see that as x increases, y also increases. So on this portion of the graph, we say that the function is increasing. We can describe this highlighted region here of the graph as being from x's negative infinity to -3. Alright, so pick any 2 points on the graph that has x coordinates that are less than -3, and it's guaranteed that for those 2 points, as x increases, y will also increase. Now, we come across, as we're moving from left to right, we come across a flat portion of the graph, and the one thing that's true about every point on this interval, all the y values are the same. They have remained constant. So we want to describe this interval, and we always describe the intervals using x coordinates, and we always have the smaller number comma the larger number. So when I look at this, the coordinates of this point, I'm really wanting just the x coordinate, just the -3. So from -3 all the way to this x coordinate of +1, if you pick any 2 points and their x coordinates are between -3 and +1, then it's guaranteed that as x increases, those y values will remain constant. Then there's a change here at this point where the graph is going down. To describe this interval, we use the x coordinates. The x coordinate at this point is +1, and since on the right it's going through the arrow, we don't have an endpoint, we just have positive infinity. So that's how we describe this decreasing portion of the graph. If you pick any 2 points that are in this green region, doesn't matter which 2 points, as long as the x coordinate is bigger than 1, as x increases, guaranteed that y is decreasing. So when we look at this graph to look for symmetry, we do not see that the left hand side is a mirror image of the right hand side, so it's not an even function. Odd functions have symmetry with respect to the origin. If you rotate the graph 180 degrees and you get the same picture, the same graph, then it's an odd function. Well, this isn't a parabola, but we can think of this as concave down. And if I rotate that 180 degrees, it's concave up. That's not the same picture. So hopefully it's very clear that this is not an odd function. So therefore it's neither.